Our purpose with this work is to introduce the digestive system to our medical partners in the world. Our vision as medical students is to break the borders for all the Latin community that want to study this career or the ones that are already studying it.
It's also been commitment for all us. We love that our readers could find in our work a good source of information for their lessons.
Includes the digestive tract and it is accessory organs, which process food into molecules that can be absorbed and utilized by the cells of the body.
Food is broken down bite by bite until the molecules are small enough to be absorbed, and the ones to produce are unlimited. The digestive tract, also called an alimentary canal or gastrointestinal tract, consists of a long, continuous tube that extends from the mouth to the anus.
Digestion and absorption occur in the digestive tract. After the nutrients are absorbed, they are available to all cells in the body and are utilized by the body cells in metabolism.
First, we need to remember some important words.
Disaccharide any of a group of carbohydrates as sucrose or lactose that yield monosaccharides on hydrolysis. Peptide, a compound containing two or more amino acids in which the carboxyl group of one acid is linked to the amino group of the other.
Blood clotting is an important process that prevents excessive bleeding when a blood vessel is injured. Chyme is the semi-fluid mass of partially digested food that is expelled by the stomach.
Fistula is an abnormal anastomosis that is an abnormal connection between two hollow spaces. Atresia is a condition in which an orifice or passage in the body is closed or absent.
Pancreatic amylase, an enzyme secreted by the pancreas that digests starch. Lumen is the space of a tubular structure such as an artery or intestine.
Digestive system. Anatomy, structure, and function. The digestive system consists in the digestive tract, a tube extending from the mouth to the anus, and its associated accessory organs. Primary glands, which secrete fluids into the digestive tract. The digestive tract is also called the alimentary tract. The term gastrointestinal tract only refers to the stomach and intestine, but is often used as a synonym for the digestive tract. Regions of the digestive tract include mouth or oral cavity, which has salivary glands, and tonsil as accessory organs, larynx or throat, tubular mucous glands, esophagus with tubular mucous glands, stomach which contains many tube-like glands. The small intestine consisting of the duodenum and ileum with the liver, gallbladder, pancreas as major accessory organ. Large intestine include colon, rectum, mucous gland, and the anus. The digestive system can be divided functionally in ingestion and digestion. Ingestion is the introduction of solid or liquid food into the stomach. The normal route of ingestion is through the oral cavity. Digestion is the breakdown of large organ molecules into their component parts. Carbohydrates into monosaccharides, proteins into amino acids, and triglycerides into fatty acids and glycerol. Digestion can be divided in mechanical and chemical. Mechanical digestion. Muscular movement of the digestive tract physically break down food into smaller parts. Digestion of the large molecules into their component parts must be accomplished before they can absorb the digestive tract. Chemical digestion. Hydrolysis reaction hydrate by enzyme chemical breakdown food particles to nutrient molecules small enough to be absorbed. Minerals and water are not broken down before being absorbed. Vitamins are also absorbed without digestion and lose their function of the structure is altered by digestion. Secretion. Enzymes and the digestive fluid secreted by the digestive tract and its accessory organs facilitate chemical digestion. Absorption. is the movement of the molecules of the digestive tract into the circulation or the lymphatic system. Molecules, parts of the digestive tract, be simply diffusion, facilitate diffusion, active transport or co-transport. Muscular movement to the GI tract. Principal digestive tube movements are three: peristalsis, mixing, and segmentation. Peristalsis, wave-like movement that occurs from the oropharynx to the rectum, allowing GI tract to push food particles toward the anus. Mixing. Mixing motion into the oral cavity and stomach that allows the GI tract to do repetitive breakdown food into smaller particles using mechanical digestion. Segmentation. Regions of the small intestine contracting and relaxing independently, allowing the small intestine to digest it and absorb more efficiently.
Esophagus. The esophagus is a muscular tube that connects the pharynx to the stomach. The esophagus is about 25 centimeters long and 2 centimeters in diameter when relaxed. It is located just posterior to the trachea in the neck and thoracic region of the body and passes through the esophageal hiatus of the diaphragm on its way to the stomach. At the superior end of the esophagus is the upper esophageal sphincter that keeps the esophagus closed where it meets the pharynx. The upper esophageal sphincter opens only during the process of swallowing to permit food to pass into the esophagus. At the inferior end of the esophagus, the lower esophageal sphincter opens for the purpose of permitting food to pass from the esophagus into the stomach. The esophagus is made of four distinct tissue layers: the mucosal layer forms the inner lining of the esophagus and the only tissue layer that is in direct contact with substance passing through the esophagus. Mucous gland in the mucosa produces mucus to lubricate the esophagus and help shield the mucosa from stomach acid. Deep to the mucosa is the submucosal layer that contains connective tissue and provides blood and nerve supply to the mucosa and the other tissue of the esophagus. Surrounding the submucosa is the muscular layer that allows the esophagus to contract and space to move substance. Finally, the adventitial layer forms an outer covering of loose connective tissue around the esophagus and attaches it loosely to the surrounding organs. The esophagus is involved in the process of swallowing and peristalsis to move sustenance from the mouth to the stomach. The swallowing food begins in the mouth and continues with the contract of skeletal muscle in the pharynx and the esophagus. The upper esophageal sphincter dilates to permit the swallowed substance to enter the esophagus. From this point, gate of the muscular contract Kelly peristalsis move food toward the stomach. Stomach. The stomach is a rounded and hollow organ located just inferior to the diaphragm in the left part of the abdominal cavity, located between the esophagus and the duodenum. The stomach is a roundly crescent-shaped enlargement of the gastrointestinal tract. Contains two sphincters at both ends to regulate food movement: cardiac sphincter and pyloric sphincter. Divided into four regions: cardiac stomach, fundic stomach, body of stomach, and pyloric stomach. Contain thick folds for providing larger surface area for expansion, secretion, digestion, and summer absorption. The innermost layer of the stomach is known as the mucosa and is made of mucosa membrane. The mucosa membrane of the stomach contains simple columnar epithelium tissue with many exocrine cells. The musculature is made of three layers of smooth muscle tissue arranged with its fibers running in three different directions. This layer of smooth muscle allows the stomach to contract to mix and propel food through the digestive tract. The outermost layer of the stomach surrounding the muscular layer is the serosa. Gastric secretory cells. Chief cells secrete pepsinogen. Parent cells secrete acid hydrochloride. Mucous cells secrete mucus and alkaline substance. G cells secrete a hormone called gastrin. Protein digestion begins with pepsin, resulting in peptides. Lipid digestion begins with gastric lipases, which can only break down certain lipids such as butterfat, resulting in fatty acids. The result of all this mixing, chemical digestion, secretion, and absorption is a yellowish paste called chyme, which will be passed on the intestine.
Liver. The liver is the largest gland in the body. It is situated in the right upper quadrant of the abdomen. It is covered by Gleason's capsule, a visceral continuation of the peritoneum. The liver has a lot of functions. It removes potentially toxic byproducts of certain medications, prevents shortages of nutrients by storing vitamins, minerals, and sugar, metabolizes or breaks down nutrients from food to produce energy when needed, produces most protein needed by the body, helps your body fight infection by removing bacteria from the blood, produces most of the substances that regulate blood clotting, produces bile, a compound needed to digest fat and to absorb vitamins A, D, E, and K. It has two major lobes, right and left, and two accessory lobes, quadrate and caudate. The liver receives about 1.5 liters of blood per minute from two sources: the portal vein, which is formed by the confluence of the superior mesenteric vein and the splenic veins. These vessels pour their blood into the sinusoids, which drain into central veins, and these coalesce, forming hepatic veins, which drain into the inferior venae cavae. Hepatic lobule. The hepatic lobule is the structural unit of the liver, which is hexagonal or pentagonal in shape. Each lobule consists of radiating columns of hepatocytes around a central vein and surrounded by 4 to 6 portal tracts, constituted by one bile duct, one branch of the hepatic artery, and one portal vein. Hepatic sinusoid lining cells. There are 4 types of hepatic sinusoid lining cells. They make up 6% of all the liver parenchyma. They include endothelial cells, Kupffer cells, hepatic stellate cells, and pit cells. Metabolic functions. Carbohydrate metabolism. The liver has a central role in maintaining blood glucose within a narrow margin. Protein metabolism. The liver manufactures and exports most of plasma proteins, enzymes, and blood clotting factors. Amino acid metabolism. The liver is the most important organ in controlling the plasma concentration of amino acids, formation and conversion. Gallbladder is a small sac located on the inferior visceral surface of the liver. It stores and concentrates bile secreted by the liver. Regulation of bile release. First, chyme with fat enters the small intestine. Then cells of the intestinal mucosa secrete the hormone cholecystokinin into the bloodstream. Cholecystokinin stimulates the muscular layer of gallbladder wall to contract. Bile passes down the cystic duct and common bile duct to duodenum. The hepatopancreatic sphincter relaxes and bile enters duodenum. The bile helps the digestive process by breaking up fats. It also drains waste product from the liver into the duodenum.
Pancreas. The pancreas is located behind the stomach in the upper left abdomen. It is surrounded by other organs including the small intestine, liver, and spleen. The pancreas is divided in 4 general regions.
The white part, called the hepatopancreas, is positioned toward the center of the abdomen, at the duodenum, whereas the stomach meets the first part of the small intestine. This is where the stomach empties partially digested food into the intestine, and the pancreas releases digestive enzymes into the contents. The central sections are the neck and body. The pancreas has two main functions: an exocrine function that helps in digestion and endocrine function that regulates blood sugar. 95% of the pancreas is composed of exocrine tissue. The secretion of pancreatic juice by the pancreatic interductal cells produce sodium bicarbonate, which helps neutralize the acid gastric contents. Acinar cells of the exocrine pancreas produce a variety of digestive enzymes to break down food substance into smaller absorbable molecules. Enzymes: pancreatic amylase digests polysaccharides into disaccharides, pancreatic proteinase digests peptidase into amino acid, and pancreatic lipase digests triglycerides into fatty acid. Only 2% of pancreas mass is divided into islets, Langerhans, which produce insulin and glucagon, hormones that regulate blood sugar and carbonate metabolism. Small intestine. The small intestine are between the stomach and the large intestine. The primary function of the small intestine is the absorption of nutrients and minerals from food. The small intestine have three distinct regions: the duodenum, jejunum, and ileum. The duodenum receives bile and pancreatic juice through the pancreatic duct, controlled by the sphincter of Oddi. The internal walls are covered in finger-like tissue called villi. Each of these villi is covered in even smaller finger-like structure called microvilli. These villi and microvilli increase the surface available for the absorption of nutrients. Once fully reduced to a chemical level to molecules, they are going to be absorbed, pass through the walls to the intestine to the bloodstream. Peristalsis and contraction of the muscle walls is the force that propels matter through the small intestine. It is a slow process, allowing the food matter to mix with the digestive juices.
Most common diseases of the digestive system. Many diseases of the digestive system can affect the normal functioning of the system. There can be problems with the esophagus, intestines, stomach lining, or even liver and gallbladder. These problems can affect the way your digestive system works. In the first place, we have esophageal problems. These problems are either congenital or non-congenital. Congenital problems usually occur at birth. The most common problem is tracheoesophageal fistula, which refers to a connection between the trachea and the esophagus. Some babies are born with esophageal atresia, which means the esophagus does not open into the stomach, but instead comes to a dead end. It requires surgery. The most common of non-congenital problem is esophagitis. It is inflammation of the esophagus caused by certain medications, infections, or gastroesophageal reflux disease. The problems of the stomach and intestines are as follows. Diarrhea and constipation are probably the most common digestive system disease. When muscle contractions move the food too quickly through the intestines, you will develop diarrhea. If it moves too slowly, you will develop constipation. Other common problems with the stomach and intestines include the following. Appendicitis. It refers to inflammation of the appendix and usually requires surgery. The most common symptoms are fever, abdominal pain, vomiting, and loss of appetite. Helicobacter pylori is the cause of the gastritis and peptic ulcers. Overuse of certain medications may damage the protective mucous coating of the stomach, making it possible for stomach acids to cause peptic ulcers. Celiac disease. This autoimmune disease triggers an allergic reaction when you eat a protein called gluten, which is in rye, wheat, barley, and a wide range of foods. Problems with pancreas, liver, and gallbladder. The most common issues include the following. Cystic fibrosis. This chronic inherited illness affects the lungs and produces the mucus that sometimes blocks the passageways in the pancreas. Hepatitis. It leads to the inflammation of the liver and causes serious symptoms. It can be viral hepatitis.
Digestion is a crucial body function in which many different organ systems work together. By coordinating with the other systems in the body, our digestive system is able to ingest food, process the nutrients found in food, and eliminate the wastage.
This coordination is crucial because this function can result if the other body systems are not working together. This coordination helps to ensure that we are able to function as human beings.